Our webinar today will start with an intro to ARC Publishing and Washington Post, then talk about Akamai-as-code, tools and techniques, followed by demos of those tools. Please welcome our speakers for today. Yair Greenbaum, our engagement manager at Akamai, who has been with the company for over 10 years and working with the Washington Post for 3 years, and Ian Baker, a technical director with the Washington Post and ARC Publishing for the past 12 years and has been working with Akamai for 10 years. That said, let's get started. Yair, take it away.
Thank you, Rachel. Thank you, everybody, for being here. I'm excited to be here. Hey, Ian, how are you today?
Doing pretty good. Ready to talk with everybody here about how we've been using Akamai APIs.
Awesome. Let's kick it off then. Ian, you want to take it?
Sure. So what is ARC Publishing? ARC Publishing is a cloud-based CMS that was originally built for the Washington Post editorial newsroom. It's a modern CMS built on AWS, which uses Akamai for both content distribution and for web security.
Awesome. So let's talk about the numbers. So we launched ARC Publishing on Akamai about 2.5 years ago. We grew from 0 to over 1,100 properties, sites on the platform. We have over 1,000 configurations, which is almost one-to-one with properties. Configurations hold the settings and the rules to deliver a website. We have 939 CP codes, content provider codes, which is used for billing and reporting. For April of 2020, we did 7.5 billion page views for all of ARC with 1.5 billion unique users. The products that we use are Image Manager, which basically allows smart image manipulation on the edge. We're using Cloudlets, which is edge logic that provides stuff like redirection, A/B testing, etc. And we're using Akamai security products, web firewall at the edge, bot detection, etc. So over here are some of the logos for ARC customers that we deliver on the Akamai platform. As you can see, some of them are very well known: Boston Globe, Daily News, and more. Since all of our configs are based on the same template, when we need to make a change, we make it to all of our configs at once. This means hundreds or over 1,000 configs at the same time being changed. On top of that, we launch between 3 to 5 new customers every week. Each one of them will have 3 configs: sandbox, dev, and prod. So how do you manage modifying over 1,000 configs at the same time? How do you manage launching 30 to 40 new sites per month?
So previously, we did it pretty much how everybody else was doing it, with a bunch of people in the Akamai Control Center, creating and cloning properties, adding host names. Everything was very manual. Now, managing it is a lot easier with the automation. We're able to focus a little more on providing better answers to customer questions and helping them out a lot more with custom requests that they've got. How did we get there? How did we get to managing that many configs? We templatized our input a few years back, which allowed us to look at what changes we were getting from clients, what requests were repetitive, what were requests that we saw across clients. And then we focused on automating those particular workflows, whether it was initial creation of a site, whether it was adding a domain, forcing SSL. Automating those allowed our staff time to work on custom requests rather than just clicking around inside of Luna.
Great. Hey, Ian, I remember when we started about 2 years ago, even as recent as last year when we presented at the Edge conference, you were still using CLI for managing your changes. I know you're now using Akamai APIs. Can you talk a little bit about this process?
Sure. When we started, CLI was the easy path. It was just myself doing config changes, and we needed a way to make changes part of a code pipeline and provide some sort of links to our Jira tickets. So I would do a commit into GitHub, and then that would kick off a series of activations or a series of processes which create a new version, activate it in staging, and then activate it in production. Now, we pretty quickly ran into problems with this because the changes were linear. It would push a new version, and then it would push that version to staging. And if I had another change, I had to wait for that process to finish. So these parallel changes became blocking to each other. Also, if we did bulk activations, we would run into that same blocking problem, but for a day or two while the pipeline churned through 30, 40, 50, 100, 200 configurations. So because of that, we sort of stepped back and said, what do we want to do with version 2? What are the things we really want to focus on? Here you can see we wanted better controls around the JSON. We wanted better auditing of the events. We wanted to be able to do quick bulk activations. And we wanted it to integrate a little bit better with the existing tools that we already had, which were based out of Slack. The way we went about this was to build a series of APIs that interacted directly with Akamai's APIs. And then around those, we built a series of step functions. We had used step functions previously inside of Arc, and they were good for sort of linking together events that had long durations or multiple loop steps. And it was a technology that we were able to use very effectively with the Akamai APIs. Some of the things like property activations would take 12 minutes, or certificate validations. And in our case, we're handing off certificate validations to a client who might take days to put them in. So we needed something that was pretty flexible as far as executing actions. And then around those step functions, we added Slackbot integrations, which allows our staff to kick off a Slackbot command. We get updates back inside of a channel, and we can interact with the step functions via Slackbot pretty efficiently. Now, we could have done all of this by saying we're going to wrap all of this around the CLI, but we wanted to use the APIs specifically because it meant we weren't linked to the CLI logic. We could create CP codes independently of creating sites. We could create a brand new empty site and upload a rules JSON to it later. We could change the group, change the product code, change other items about a property that we couldn't normally do if we were cloning that only out of a configuration that already existed inside of Akamai. And honestly, probably the biggest thing is it was easier for us to get debug and error information out of the APIs than it was to parse the output from the CLI.
So let's go into the details a little bit more. We are creating a new Ion config for each customer. All of our configs are based on a golden master config. After cloning the template, we are creating a customer-specific section at the bottom of the config. The customer section usually includes rules such as specific redirects, legacy origin, GDPR, SSL, etc. As we know, all Akamai configs have a JSON representation. Here is a JSON file for one of Arc's configs. Our goal is to enable users to work inside their DevOps environment at their speed and their scale. Compared to our traditional users that would only do CDN operations and work entirely inside the Akamai Control Center, we now see a new type of user, mainly developers that need something else. They want to be able to push more code quickly, test, and be able to react fast. Everything we talk about today is going to focus on that. How to make the process faster and more efficient to our users. The question that comes up with many of our customers and people that attend the webinars is, what the hell is DevOps? So let's start by making sure we are all on the same page with that. DevOps is a set of software development practices that combines software development and information technology to shorten the development lifecycle while delivering features, fixes, and updates frequently in close alignment with business objectives. That was long.
Yeah.
What does that mean? It's all about speed. We want to be able to deliver quickly and frequently. Customers expect Akamai to snap into their existing infrastructure. They don't want their development process to stop in order to make changes or deploy new configs on Akamai. Let's look at a traditional CI/CD pipeline as a developer, leaving Akamai out of the pictures for now. Think about any piece of code or project you are developing in your CI/CD pipeline. The focus is on speed. A few years ago, we were seeing customers go through 2 weeks release cycles with extended time for development and testing. I can tell you that today, one of our biggest commerce customer is going through 72 releases a day. So speed, frequency, and convenience is key. And we have done a lot of work at Akamai over the past few years to be able to provide that. So let's look at the diagram again. As a developers, you have a Git repository where you're storing all your code. You have a Jenkins job running, kicking off some builds and tests. You might be using Terraform or Chef provisioning your architecture, and you might be using Splunk or Sumo for monitoring. This is a typical DevOps savvy workflow we see with many of our customers. How can Akamai fit into this workflow? So it can fit with Akamai APIs. Over the past few years, we built APIs for everything Akamai, from Property Manager API that allows you to create and manage Akamai configurations, to Fast Purge, traffic management, Fast DNS, CPS for SSL certificates and cloudlets. Everything, or almost everything, can be done via API. Our goal with this effort is to allow our customers that want that to be completely Akamai without the Akamai Control Center. Don't worry, ACC, the Akamai portal, is not going anywhere. We just enabled a new way to integrate Akamai into your development pipeline without requiring developers to access the GUI management console. Okay, let's go into demos.
So with everything you just heard in mind, let's walk through how Arc is using some of these APIs to get what are our most common tasks done. We're going to start with creating a new property, adding a host name to that property, and then activating a whole bunch of properties. So here, we're creating a new property from scratch, not cloning it. We're using the PAPI properties and activations endpoints and the CP codes endpoints to create the config, make a CP code for it, upload new rules to it, add an internal host name for it, and then activate the configuration on the network.
Can you explain the need for an internal host name here?
It's mainly to get the property activated. Clients might spend a month or more working on development for their sites before they're actually ready to cut over their primary host name. So we add an internal host name that they can use to just visit the site and see how it will look when their www domain name is moved over to it. They won't have to set up a host file. They don't need to set up any testing infrastructure to be able to look at the site. They can just put in this default name. But mainly, it allows us to get the config active on the network and ready for subsequent changes without having to wait for any primary domain, www domain name to be added.
Great. So let's go into the demo and see how this works.
Okay. So as we mentioned a little earlier, we wanted to integrate with our existing tools that were all Slack-based. As we start into the create property process, you can see I'm asking Gopher to go ahead and start creation of a property for us. In this case, it's going to be the demo Akamai sandbox property, and we're going to use version 1.2 of our internal template that we talked about a little bit earlier. And you can see as we switch over and look at the step function, that the step function is already well into its workflow. It's already gone through, it's created the property, it's created the CP code to go with that property, added the CP code to the reporting group that we use for billing, it's added a new rule tree, added a host name to the property, and now it's activating that property on the Akamai staging network. Switching over to Akamai, you can see what we would normally see if we were working in Control Center, version 2, which is where the rule tree was uploaded to and the host name was added to. You can see demo Akamai sandbox. This is our internal host name that we use to get the property activated and running. And here you see all of the content that we would normally put it into customer configuration, including, as you see here, a content provider code, which is specific to this particular site. And here you can see the property is activating on the staging network, and staging and production is active. Now, the last bit that happens in our step function is that once we're done with activation in the production network, we upsert data into our internal Dynamo database. This basically holds a bunch of information about the property that we use to display internally and to the client. So here you can see demo Akamai Sandbox. We can expand this out and see the host names that were added, stuff that you might not see in Control Center, the edge key ID that it was associated to, the active staging and production versions, and then also, as we talked about before, that customer template or customer part of the template, all of that JSON is now stored inside of this database. And this is what allows us to go and create a new version and still preserve the customer specific information out of it. So that's it. Customer configuration is complete.
Okay. So after we created the property, the config, with an internal host name, like you explained, Ian, we need to start being more specific. Over here, we're adding the actual host name, the www.site.com, to the config and the certificate. The basic steps are adding the host name to the property, to the config, then moving on to Edge DNS, creating a CNAME for our client to use. Then we're adding the host name to the SSL certificate that has already been created for the client. And we're waiting for the certificate validation to succeed.
Yep. And just to cover some of the endpoints that we're using here, we're using those same property or PAPI property and activation endpoints that we saw earlier. Yeah, here we're using the same PAPI properties and activations host endpoints that you saw earlier. We're also using the Edge DNS config DNS endpoints, as well as the CPS enrollment endpoints.
Awesome.
Okay, so let's get started adding a host name to the property that we just created. Like with the last process, this starts with a Slack command. We're going to ask Gopher to add a host name to the demo Akamai Sandbox property and a host name of arc1.akamai.com. In this case, because we're going to have a lot more back and forth with adding a host name, we actually get some additional output in our automation room. Here, the bot is telling us that it successfully got the edge key that had already been created for the client and that it started the process of adding the host name. Now, switching over and looking at that in the step function, you can see it's running. You can see our initial input, which was add host name of arc1.akamai.com. And the first couple steps of the workflow for add host names are the same as they were for the create site. We're going to add host name, we're going to activate in staging, and you can see it just switched to activate into production at this point. And the rest of this workflow is around adding DNS and CPS endpoints. But let's go check the Akamai property first. And we can see we now have version 3. It's already activating into in production network. When we look at this property, we're going to see that it has arc1.akamai.com on it. And you'll note that the certificate and edge host name were not in that step function, but that's because we had already created the cert and edge key name when the client was added to Arc. Now we're going to go back over and take a look at the Slack room. And here you can see the bot has been continuously giving us more information. It's told us we skip forward here, and now the version is active in production. Here, it's going to create an Edge DNS entry that the client will use when they are going to point this domain to Arc as a CNAME. See some more commands coming in here. We then switch over and go to CPS. We are getting the enrollment ID or data about their certificate. We are making a change to that. We have to wait one loop for that change to be processed before we actually successfully get the enrollment. Then we update it to include the domain name that we want to add, in this arc1.akamai.com. And then we basically start to sleep again. We're waiting for the challenges for that domain name that we just added to come back from Let's Encrypt. So here you see a fail. And now if we go over and look at the step function, you'll see that a lot of the flow is now, that used to be previously gray, is now green. When I said earlier we got a fail when we were waiting for the challenges, we'll continue to loop on that until Let's Encrypt comes back with that data. And so here you can see we've gotten all the way down through the step function, and now we're actually on waiting for validation of the challenges, which means if we go back to our Slack room, we can see that the bot has now spit out the challenge data, gotten this back from Let's Encrypt via CPS, and the client can do a redirect, they can do an HTTP token response or a DNS response. They can choose whichever method they like. And now the bot goes into a sleep mode. It's going to check back on a regular basis for the next 7 days to see if these challenges have been completed. We're handing this information off to a client. A lot of times it takes them a long while to get the challenges in. And once the challenges are complete and the certificate is deployed out to production, the last step in the step function actually writes this domain name along with its edge host ID into the Dynamo table under the hostnames tree. So now we can then come back and reference that data in future steps. And at that point, the process is complete. The client's hostname has been added to the configuration, and we're ready to accept that traffic.
We reviewed the process of launching a new customer, creating a new config, SSL certificate, adding a hostname, testing, etc. Now that the site is launched, can you talk about the process of making bulk changes? How do you go about making changes to hundreds of Akamai configs at the same time?
Sure. So this doesn't use any endpoints we haven't already discussed, the PAPI activations endpoint. But the difference here is that since we're doing things in bulk, we're doing a lot of checks for CP code changes, origin hostname changes, any cache ID rules that are present in the configuration. We want to make sure that we don't push out a configuration that changes cache offload or changes origin traffic or does something that we don't expect out of it in bulk. These tend to have a detrimental effect on your origins when you do them hundreds or 1,000 properties at a time. We also do some checks on active versions in production, just in case somebody was inside Akamai Control Center and did a manual change on a configuration. We want to set a warning up to ensure that we don't overwrite a change that somebody had done manually and was never synced back into our repo or into our configuration database.
Makes sense.
So rather than starting with the gopher command, let's walk through the process that the activation step functions are using. Here you can see the process flow. First, we do some input validation, and then we go to Akamai and actually retrieve the current production version like I just mentioned. From there, we actually run a completely separate step function that goes out and pulls down the JSON for the active property and compares it with what our internal data is saying about the on-deck version. Here you can see some of the checks that we're doing. We're looking for PM user origin and PM user page builder. Those are two variables that could cause a change in cache. We're also doing behavior checks. We're looking at the origin rule, origin behavior, the default rule, forward host header, cache key host name, origin host name, and also a CP code value. And these checks are very simple. What's the current version of production and what's the new version that we're about to activate? If they don't match, raise an exception. So from there, we actually send a message back into Slack to say, do you want to proceed? As long as you say yes, that goes into executing the activation. It's the same for production or staging network. We basically loop through all the properties, record the new active version back up into Dynamo, log any failed activations back to the Slack channel to let us know that something didn't go right, and then do a little cleanup to make sure we're ready for the next activation. But now we're going to kick off the gopher command. You can see here the upgrade that was done to these properties, which placed a new on-deck version. And so we're going to go through and we're going to upgrade all of the Akamai sandbox sites that we have created, and we're going to do this on staging network. The delivery bot is echoing back to us what we just gave it. You'll notice question marks for some of these. This is because we don't have a failback version yet. This is the first time we've run an activate step function on these properties. We don't consider the initial create and add hostname as a version that we want to fail back out of. Here it's telling us that the 10 properties have passed the validation checks, which is what we just saw. We're going to confirm that we want to proceed with this activation. We're going to hit confirm again. And then, of course, through the magic of video recording, we can jump directly to when staging activation has finished. There we go. At this point, all these properties are now active on the staging network, and we could proceed to activate them in production. We could run staging and then production back to back if we wanted to. And we could use this command to run a activation on every single Arc property if we wanted to, even hundreds of configs all in parallel. So this is a really powerful tool for us that we use it when we're doing platform upgrades, or if we've got an emergency change that needs to go out to clients. It makes it very easy for us to activate a ton of configurations.
Awesome. What are your go-to tools and procedures to follow when things don't work as planned, Ian?
The primary advice I would give is just make your code modular. Be able to pull out a single API call and replay it locally, or a series of API calls and play them back, locally to determine what's going on. Log enough that you can do that, like know what input was given to your function and know what the responses were that you got back from the Akamai endpoints. And then obviously, once you've identified what the problem is, you're getting a specific status code back and a specific message. Take that and go to your Akamai resources and determine what that error code means, or what you can do to get more data about that particular error code. I will say that in our case, a lot of our failures have been sort of process related, this before that. And so understanding your workflow and making sure that your steps are being executed in the right order is critical to being able to troubleshoot what is going on. If you're trying to activate something doesn't have a host name on it, it's going to fail. In our case, the step functions provide a really good visual workflow of what is happening and in what order, and we can guarantee that things don't process out of order. But if you're not using a framework like that, log, your order of operations for your requests, especially when these things occur over hours or days.
Great. Thank you for that, Ian. And this was a great kind of like debugging 101. So let's talk about lessons learned. What are some of the lessons you have learned over the past 2 years going through this process?
So don't expect short-term execution all the time. Activations and cert pushes take time, and there's a lot of steps that are going on inside of Akamai. Even when you tell it to activate something, it is validating the JSON. It's deploying it to a certain set of edge nodes, and then to international nodes, and then to US nodes. There's a lot of steps that go on that take time, and build your processes around that. If you expect that you're going to hit activate and then come back 2 seconds later and it's going to give you the next status, it's not going to work. Secondly, if you do this at any sort of scale, build multi-threaded. In our case, that's the problem that we ran into going from CLI. Changes will stack up, things will run longer than you expect, and you'll end up with a pipeline that is backed up, waiting for changes to occur. 3, get your framework out early and put it in the hands of the staff that is currently doing your Akamai work. There is a lot of latent or inherent knowledge or process that people follow when they are inside of Control Center. The order by which you do things, you add a host name and you create an edge host name at that time, and then you use this edge host name somewhere else, or you're adding CP codes in a certain way to reporting groups. That information will take a lot of time to extract and sort of turn into a code process. And so the earlier you start that process, even if it's not perfect, ask your staff can you activate using this tool rather than activate using the Luna console. It's the same step, but they're doing it a different way. And it starts to give you feedback and eases you into the API path, if you will. But I can't stress how much getting it into the hands of the staff that is currently working, as early as possible will help to tease out your process and make it easier and make it faster to get on board. 4, build your framework to be flexible. We knew that we were going to be doing Slack-bot activation since it was a technology that Arc uses fairly heavily. And we built our API framework to handle activations from, a CLI command. We started with just Postman calling APIs directly. Then we migrated to using AWS step function commands, and then finally to Slack bots. But we didn't lose any development time in this. We didn't build something and then abandon it because these layers were built on top of each other, and it made it easy for us to implement a new technology on top of the framework that we already had. We didn't have to train the Slack bot on all of our Akamai process logic. It knew that because the step functions had already consumed that. And then lastly, beware of custom behaviors or advanced behaviors inside of your Akamai JSON or anything else that's custom inside of it. You will be working heavily with JSON, as you manipulate your rules tree and upload those to configs. And so anything that is pinned or locked or prevents you from uploading a blank rule tree and then replacing it with a full rule tree will cause problems as you go along. We are actually in progress right now of porting all of our older configurations that had custom behaviors and cleaning up all the custom behavior or advanced behaviors that are in them and importing them into our automation pipeline. And that's a significant amount of work, so I don't wish it upon anybody else to have to do.
Makes sense. All good lessons. Okay, let's do a quick recap. Arc Publishing is a cloud-based CMS primarily used by news publishers. It is used by news organizations all over the world. Arc is using Akamai for delivery and security. We are launching anywhere between 10 to 40 new sites every month. Everything we do on Akamai is done via APIs. We're not using the Akamai Control Center for anything. We use Property Manager API for creating a new property, uploading a JSON rule tree, adding a host name to our property, and activating it. We use CPS API for creating new certificates, adding host names to a certificate, and validating these host names. We use Edge DNS API for creating and maintaining Edge host names and DNS records. We do all of these for every site we are launching. We also use Property Manager API for making bulk changes. Sometimes we need to make changes to hundreds of configs at the same time. We use Property Manager API to do that. Thank you very much for attending our webinar. I really enjoyed it and hope you learned new things from what we showed you here.